Hey everyone, welcome back to a new video. Today we're going to be checking out the EcoFlow Delta Max. Now this sits right in the middle of their current lineup. You can get the EcoFlow Delta Pro, which is much larger, or the EcoFlow Delta Mini, which is smaller. So if you're looking at something right in the middle, this is the one you're going to want to look at. Now this comes with 2016 watt hours of capacity, and it offers two expandable batteries. So you can get up to 6,000 watt hours on this power station, making it a great backup solution. Now it has a 2400 watt pure sine wave inverter. So basically anything that you have in your house that's going to plug into a wall outlet will be able to plug into this power station and run on it. Now you can also charge this at up to 800 watts of solar, which is pretty fast. Now this power station is currently on sale for $1,899 and it MSRPs for $2,099. Now inside this power station you have lithium NCM batteries, and they are rated for 800 life cycles down to 80% capacity. So that means you can charge it up to 100%, discharge it, and charge it back up. So that's one life cycle. You can get 800 of those and still have 80% capacity. Now I know some of you are mentioning, well, Jason, why doesn't this have lithium iron phosphate? Well, lithium iron phosphate is available in the EcoFlow Delta Pro. So if you're looking for something that's meant to be cycled every single day, you might want to look at the EcoFlow Delta Pro instead of this one. I feel this one's meant perfectly for emergency backup use and for camping or other portable power, but not meant to be cycled every single day over and over, as it won't last quite as long as a lithium iron phosphate power station. Now, because of the chemistry that's in this power station in the batteries themselves, this power station is actually smaller and more compact than other power stations with similar capacities. Now, this one actually weighs a little bit less as well because that chemistry is more energy dense. So it only comes in at 48 pounds versus heavier power stations over 60 pounds. So it's pretty easy to move this one around. Now, EcoFlow offers a 2-year warranty on this product. Now, in the rest of the video, we're going to do extensive testing on the DC output, the AC inverter, and we'll do some charging demos. And at the end of the video, we'll throw this through my new power station grading system, give it a score of 1 to 10 based on its price, performance, any issues it has, and all the features. So hopefully you guys are excited. Let's go ahead and jump into the testing. Now, the first testing that I want to do on this power station is actually test the DC output. Now, all the DC output is on the back of the power station, so let's go ahead and flip this around and start our tests. Now, there are 3 different DC outputs. You have two 5521s rated at 3 amps max, and then you have a 12-volt cigarette plug rated at 10 amps max. Now, if you want to turn on the DC output, you just push this button here. Okay, so it looks like the DC output is regulated at 12.7 volts. Now, trying to max out the 12-volt socket here, I'm pulling around 10.3 to 10.4 amps, and we're getting a little bit of voltage drop through the cabling here, and it's sitting at 11.6 volts on the battery load tester. Now, you should be able to pull around 120 to 130 watts without any problems. Now, when I moved over to testing the 5521, it looks like I'm able to pull around the same amount of power, around 10.3 amps or 120 watts. So it looks like it's limited the same way as the 12-volt socket. Okay, so now I have both battery load testers connected up to the 5521 and the 12-volt socket. Let's see how many amps we can pull out of both sockets combined before it shuts off. Okay, so it looks like you can pull a little over 11 amps before it will shut off the DC output. Now, another test that I like to run on the DC output of these power stations is to make sure they don't have any auto shutoff settings or eco mode settings that turn off the DC output after a few minutes or a few hours. Now, a perfect way to test that is by plugging in a 12-volt compressor fridge, because when the compressor is running, it's pulling power and then it sits idle for a few minutes and then the compressor turns back on. So this will give a good test of the DC output to see if it will shut off if it doesn't recognize any loads. Now, this is the Set Power FC12. This is the smallest 12-volt compressor fridge I've tested on the channel. I'm super excited to see how this performs. Let's go ahead and see what it does.
Many hours later.
Okay, well, it's been about 14 hours and the fridge is still running. So it appears there are no auto shut-off settings on this power station, which is great news if you want to run a DC load for a long period of time. Now, what's really cool is this is sitting at 95% still, which means this has very little parasitic drain on the DC output. So I will be doing some further testing on both the AC and DC output, see if there is parasitic drain, so stay tuned for that later in the video. But thumbs up, very impressed with how this ran the DC load. Okay guys, the last test that I typically run on a DC output of a power station is a complete discharge test. So I have this charged up to 100%. We're going to discharge it using this battery load tester all the way down to 0 and see how many watt hours we get versus the rated capacity. So I just started the test about 2 minutes ago. Now I'm pulling around 120 watts. Now this can only support 130 watt output. So we're just pulling about 10 amps. This is gonna take a very long time. Let's go ahead and let this run and we'll come back when it's finished. Okay guys, the battery finally hit 0%. It's been about 13 and a half hours. Let's go ahead and see what the results were. Okay, so you can see we pulled a total of 1,636.46 watt hours. It ran for 13 hours and 40 minutes. And we pulled a total of 137.97 amp hours. Now, if we take this 1636 and divide it by the advertised capacity of 2016, it gives us 81.1% of the advertised capacity. Now, basically what this test is telling us is if you take this from 100% down to 0% using the DC output maxed out, you're gonna see around 1,636 watt hours. Now, unfortunately, this isn't 85%. I always like to see at least 85% of the rated output, but this is similar to what other channels have seen when they reviewed this, so I think this is pretty normal for this power station. Okay, so in the next portion of the video, I want to test the AC inverter on this power station. Now, the Delta Max is rated at 2,400 watts continuous output, and it should have a pure sine wave output with 120 volts. So let's go ahead and plug in my oscilloscope and see what results we get. Okay, so with no load on the inverter, we're seeing 120 volts output. Now swapping my meter over to oscilloscope mode, you can see we're getting a pure sine wave output with 59.9 hertz and 112 volts RMS. Now what does all this electrical jargon mean? Well, it basically means the AC inverter on this power station puts out the same type of power that you get from your wall outlet from your power company. So it should be able to run sensitive electronics and all different types of tools and appliances just fine. So now I want to run a 15-minute max load test on the AC inverter, try to get it near 2,400 watts, and we'll watch the voltage and the sine wave output during that test and make sure everything goes good over 15 minutes. Okay guys, I just started the test. You can see we're pulling right around 2,400 watts. Now it's been going for about a minute or so for me to get that load exactly where I wanted it, but we're gonna let this run for 15 minutes. Now you can see we're still putting out a pure sine wave output, and let's see what the voltage is. Wow guys, 2,400 watts and we're still getting 120 volts output. So I'll come check in at the 5-minute mark. Okay, so we just hit the 5-minute mark here on the stopwatch. We're still pulling around 2,400 watts and getting 120 volts output. Now you can definitely hear the fans running. The fans have two different levels. They kind of have a normal level and then they have a loud level. This is, basically putting out max power, so these things are running. Now what's good is the fans are loud, but the air coming out is just slightly warm. So as long as everything inside the power station stays cool, we're not going to have any issues. Let's go ahead and let this run for another 5 minutes and then we'll check back in. Okay, let's go ahead and check what the temperature is coming out of this thing. Okay, we're getting 98 degrees coming out. My room's probably around 70 degrees. So, not that warm at all. Okay, so we hit the 10-minute mark, still pulling 2,355 watts. We are getting a pure sine wave output still. And let's go ahead and check what the sound of these fans really quick. I just want to show you guys how loud this is. It's basically right around 63 decibels. Okay, so we just passed the 15-minute mark on the test. We're still getting 120 volts output and 2,347 watts. So a pretty awesome results. Let's go ahead and turn off the AC inverter. Okay, so I was able to run this for about 17 minutes at 2,400 watts, and we dropped from 96% down to 54% on the battery capacity. Now, whenever you're running a large load like this at 2,400 watts, I'd expect around 35 minutes total runtime before it hits 0%. When you're running at 2,400 watts, it's just taking a ton out of the battery. And that's the case on any of these larger power stations. Whenever you run them at max load, don't expect a very long runtime. Now the Delta Max also supports this extra feature called X-Boost technology, where you can get even more power out of the AC inverter, up to 3,400 watts. Now, whenever you want to run X-Boost technology on the inverter, you download the EcoFlow app on your smartphone and connect to the power station. And when you go to turn it on, it gives you a warning saying, hey, this only works for certain appliances that accept a wider voltage input range. Now, X-Boost technology works by dropping down the voltage of the AC inverter. Remember, this puts out 120 volts, but with X-Boost enabled, it has the ability to drop down the voltage below 100 volts if needed. Remember, it's volts times amps equals watts. And so if you want to run more appliances, you can drop down the voltage as long as they work that way. Now remember, sensitive electronics do not support lower voltages, so do not enable XBoost technology if you're trying to run sensitive electronics. Okay, so the last test that I want to run on the AC inverter of this power station is to do a complete discharge test. Now I charged it up to 100%. I have my kilowatt meter here on the back. It's going to track all the power that we pull from the battery during the discharge. Now this is rated at 2016 watt hours, so I'm hoping for at least 85% of that. So let's start the test and see what we get. Okay, so the power station hit 0% and the AC inverter shut off. So with my watt meter here, you can see we pulled 1830 watt hours. Now with this being advertised at 2016, we take 1830 divided by 2016, and that means we pulled 90.7% of the advertised capacity through an AC inverter discharge test. And that is one of the best scores that I've seen on a large power station. So very impressive results coming out of the AC inverter. Now I briefly want to talk about the parasitic drain on this power station. Now first off, what is parasitic drain? Well, that basically means if you leave an output on, like the DC output, with no load at all, how much power is this power station going to lose over time? Now usually with my testing, a large power station will lose about 1% per hour if you leave the DC output on, or about 2% per hour if you leave the AC inverter on. So if you left the AC inverter on for 4 hours, you'd come back and the battery would be 8% lower. Now what's super interesting about this power station is I did a similar test. I basically left each of the outputs on for 2 to 3 hours and I came back and each time it was at 100%. So this power station has much less parasitic drain than I've seen with other large power stations. So I'll have to continue to do more testing on this and let you know, but first thoughts, I'm very impressed with the parasitic drain on this power station. Now in this portion of the video, I want to go ahead and talk about charging the EcoFlow Delta Max. Now there are 3 different ways to charge this up. You could charge it via AC wall power, you could charge it via solar panels, or you could charge it via DC to DC charging. Let's go ahead and jump into the charging port on the back of the power station. Now all the charging inputs are under this flap on the back of the power station, and your DC to DC charging or solar charging plugs in right here. You can see it takes 11 to 100 volts DC and a max input of 10 amps. Now you plug in your AC charger here. It takes 100 to 120 volts, 50 to 60 hertz only. Now this has the ability to charge at 1800 watts, and what's awesome is there's no external charging brick. All the charging is built into the power station, so you only plug that cable in, which is absolutely awesome. Now it also has the ability to adjust between fast AC charging or slow/custom. Now if you have it on the fast setting, it'll charge at 1800 watts, and if you drop it down to slow, it defaults at 400 watts, but you can use the app to adjust that charging speed, which is pretty awesome. Now when you use the DC to DC charger off a battery or your vehicle 12 volt socket, you should expect somewhere around 100 watts charging input. And you can see it's going to take a long time to charge because it's just really slow. So 12 hours to get the remaining 50% of the battery. Now the fastest way to charge up this power station is by plugging into the wall, and I currently have it set to the fast charge setting. You see we're almost getting 1200 watts. Now I'm not sure why it's not getting 1800 watts here. It seems to be some sort of automatic charging setting. Now in the app, it is showing that it is set to 1800 watts, but here we're actually getting 1150 watts. So maybe as the percentage gets higher, it will charge faster. Now one thing I do like about the AC charging input is you have the ability to set the exact charging amount that you want. For example, right now I have it set to 200 watts in the app, and it's just hovering right under 200 watts. And if I wanted to set it to 400, I could set it to 600. Whatever I want to set is available in the app, which is really nice to have that customization. Now the next way to charge up the power station is by using solar panels. You can see I'm getting around 630 watts right now. I have 2 different solar arrays outside, but unfortunately the voltage tolerances of this power station will only work with my 720 watt array. So I have that plugged into the power station right now, and we have a little bit of high clouds right now, but you can still see we're getting excellent power input around 630 watts. Now if you were able to match the voltage up perfectly with this power station, you should be able to max out right around 800 watts. Now one big benefit to this power station is how fast it can charge. I have the solar panels plugged in and the AC adapter, and we're getting around 1860 watts. You can see we're jumping up to 1900, and I did see a peak of 2000. There we go. And that's just because we have some clouds going in and out on solar. But with solar plugged in and the AC charger enabled on fast charge, you can charge this thing extremely quick. Now, one feature that's really important for power stations is that they can be used and charged at the same time. So right now I'm actually charging up this power station at 475 watts using the AC wall charger. And then I'm powering a fridge off the DC output, charging my phone and running a small USB fan and the AC inverter, and everything is working just fine. So this power station does support pass-through charging. Now I want to take a second to talk about the app that EcoFlow offers for all their power stations. Now it's available on iPhone or Android. You download it and you can connect to the power station remotely. Now right when you see the first screen, you can actually see the watts in, the watts going out. You can see the temperature and also the state of charge, and you can turn on and off all the DC or AC outputs, which is pretty cool. Now what's even better is you can go into the settings and you can set the screen timeout. You can say when the inverter is going to shut off. You can adjust the charging speeds, which is really cool. And the best feature of all is that you can actually update the firmware and push a new firmware to the unit. So say EcoFlow found an issue with the power station, they can release a new firmware and fix a bug with the power station without having to ship the power station back and forth. So it just allows new life for a power station. If there's something wrong or if they want to add a new feature, they can push out a firmware update and then actually push it to the power stations. So neat that this offers such a cool app. Okay guys, we've come to the part of the video where we go through the actual grading process on this power station and give it a score of 1 to 10. Now the reason I give it a score is so you can compare it to the competition and see how it stacks up on price, performance, features, and if there are any issues with this that you need to be aware of. So let's go ahead and jump right into the grading system. Number 1, can this power station charge up in 4 hours or less from 0% up to 100%? Yes, this actually charges super fast. If you plug it in the wall, it'll charge up to 1800 watts. And if you have solar panels and the wall charger plugged in, you can charge it 2000 watts plus. So this charges very quickly. Number 2, does this power station support pass-through charging or the ability to charge it at the same time as discharging it? Yes, you can use the power station while charging it, no issues there. Number 3, does this have a pure sine wave inverter? Yes, we tested it, put out 120 volts and a pure sine wave under both a load and sitting idle, so no issues there at all. Number 4, does this power station have a regulated DC output? Yes, it's regulated at 12.7 volts. Number 5, does this power station have an informational display? The display will show you everything you need to know, like the watts in, the watts out. It'll tell you your battery percentage, and it also give you an estimated time remaining and also show what outputs are enabled or disabled. So the display on this power station is really good. Number 6, does this have any auto shut off settings? Now I tested both the AC inverter and the DC output and none of them shut off automatically. Now there is a setting in the app that you can turn this on if you want, but it is disabled by default. Number 7, let's talk about the USB output on this power station. Now, does it support USB output power delivery? Yes, it does. It actually supports 2 100 watt output ports. Now, are these ports bidirectional? No, they aren't. So this gets a score of 0.66 out of 1 point available because it loses 0.33 points as not having bidirectional USB ports. Number 8, does this meet 85% of its advertised capacity? Now this is advertised to have 2016 watt hours, and during our AC test, we were able to get 90% out of the AC inverter, which is pretty awesome. That's the best score that I've seen on a power station so far testing the AC inverter. So yes, this definitely gets a point there. Number 9, can this charge up in 5 hours or less using solar panels? Now, because this can take 800 watts input on solar, it can charge up in around 2.5 hours, which is pretty awesome. So it definitely passes that test. And number 10, one of the most important features, how is the price of this power station versus its capacity? Now, I like to measure and think that most power stations come in at a good deal if they're 80 cents a watt hour or less. And this one comes in at 94 cents a watt hour. So it's a little bit pricey compared to some of the other competition on the market. And it does offer quite a few other features, but for the price, you do have to think about it if it's going to be worth it or if it's just better to go with a cheaper power station that offers the similar features but a lesser price. So after going through all those points, this comes out with a total of 8.66 points on the grading scale. So a pretty decent score for how well this power station performs. Now, the only things that took that score down were basically the non-bidirectional USB ports and the price being higher than 80 cents a watt hour. Okay, so now that we have the grading system done on this power station, I just want to talk a little bit about cost per life cycle on this power station compared to the EcoFlow Delta Pro, because they have two different chemistries and I want to explain how that works. So the chemistry in this one is lithium NCM, and it gets 800 cycles down to 80% capacity. So that means after 800 cycles, you're going to use the top 20% of the battery. Now, that means it'll still have 80% capacity and you can keep using it, but it's just a way to measure how fast the capacity will lower on the power station as you use it. Now, if you look at the Delta Pro, that one actually has 3,500 life cycles down to 80%. And that's because it has lithium iron phosphate in it. So let's compare both of these chemistries really quick and the cost per cycle. So this comes in at $18.99 on sale. So let's just take 20% of that cost and divide it by 800, and that will actually come out to be 47 cents per life cycle. So you're basically taking 47 cents of the original cost every time you charge it up and discharge it. So one life cycle is going to be 47 cents of the original cost of the power station. So let's take the Delta Pro and compare it to its cost. So the Delta Pro is much more expensive, has a lot more capacity. Now that comes out to be $35.99, so $3,599. So if we take 20% of that cost and divide it by 3,500, because it's rated at 3,500 life cycles, down to 80%, it comes out to be 20 cents per life cycle. So you can see that there is an advantage to going with lithium iron phosphate just because you get many more life cycles and much more usage out of the power station. Now, does this matter if you're using the power station, a couple times a month? Not at all. If you're not planning to use this power station every single day, then I probably wouldn't even worry about it. If you want to have the backup power and you want to have the powerful inverter, the app, and everything like that, you want to use it for camping and not, something every single day, then you want to go for this one. Now, if you want to have a backup that you're using every single day over and over, and you want to get the most out of your money, you may be interested in going with the Delta Pro. Now, I've also put this out on my power station grading sheet for every single power station that I've tested, so you can actually see the cycles for the top 20% on every single power station. For example, the Alcatel P2001 comes in at 15 cents, the Blue Yeti AC200P comes in at 8 cents, and this one at 47 cents, and the Delta Pro at 20 cents. So just a little bit of education on pricing so you guys can see how they differ. Okay, so we're basically coming to the end of the video, and I just want to give a few final thoughts about the EcoFlow Delta Max. Now, this isn't going to be a recommendation or not to purchase this because each of you have a different use case and only you guys can make that decision. So the purpose of this video is to give you guys all the facts that I know about this power station and let you guys decide if it's right for you. Now, I've been very impressed with the build quality and performance. Remember, this actually did one of the best efficiency outputs on the AC inverter at 90%. I haven't had a power station test that high. And also the parasitic drain was really good on this. So if you wanted to use this in a camping scenario with a DC powered fridge, it should do an excellent job at that. Now, this charges extremely fast. Remember, 1800 watts through the wall adapter and up to 800 watts on the solar input, and does offer the expandable battery options. So just a lot of things about this power station that are very good. Now, you have to ask, how are you going to be using it? Now, with the lithium NCM chemistry inside with the 800 life cycles to 80%. Now, it is going to degrade a little bit faster than a lithium iron phosphate power station, but are you going to be using it that much to even make a difference? So if you're going to use this for a backup if the power goes out, or if you're going to use it throughout camping during the year, if you put this in a teardrop camper or something like that, is it going to matter? You're probably not even going to notice the degradation on the batteries. The only thing that would really make a difference is if you're going to be using this every single day, you'll start noticing after a couple years that you're not getting 100% capacity. You've kind of gotten down to that 80% level. So just give it some thought and determine if this is going to be right for you. If you're looking for something that's going to get a little bit longer life cycles, you're probably going to want to look at the Delta Pro that has the lithium iron phosphate batteries in it. It gets 3,500 life cycles. So I'd love to hear your thoughts on this power station and how you guys would plan to use this. Let me know what you think about it down in the comments below. Now, I always try to give my most honest and transparent thoughts about these power stations. I don't really have any intention to, make you buy this or not. So hopefully you guys feel that these reviews are just honest and providing the most useful information that I can. Anyway guys, thank you so much for watching. I hope you guys are subscribed to the channel so you can see future videos. We'll see you guys in the next one.